Today, section 9.2, we're going to talk about graphing parabolas. A parabola is a special shape that comes from the equation of something with an x squared in it. So I might ask you to graph y equals x squared. The first thing you should think is this graph is not a line. Why is that the first thing you should think? Because it has an exponent. If it has an exponent, it is not going to be a line. So if I draw this picture and I get a line, what do I know?
It's wrong.
I did it wrong, really wrong. All right, what I would probably do, if I was going to graph this for the first time and I didn't know anything about it, I would probably build myself a little table. And I would pick, 0, and I'd pick a couple of my favorite positive numbers, and I'd pick a couple of my favorite negative numbers.
6.
So I'm going to use 0. And then I'm going to pick my favorite two positive numbers.
-1,
1 and 2. And then my favorite two negative numbers are -1 and -2. And I'm going to plug those in. What's 0 squared? 0. What's 1 squared? 1. What's 2 squared? 4. What's -1 squared? +1. Because -1 squared.
Because I feel like if it's in parentheses, it's supposed to be negative. Oh, you put it in parentheses.
When you plug in a negative number, always put it in parentheses. Because this symbol means x times x.
See, that's how I was seeing it. It's just -1.
So it means -1 times -1, which would be +1. -2 squared is 4. All right, so drawing a picture, I have 0, 0. That's right there at the origin. 1, 1. 2, 4. -1, 1. And -2, 4. I connect my dots with a nice smooth curve, not a line. And I think it looks like that. And that shape is called a parabola. Yeah. Oh, I'm not done with that. Okay, so a couple things you should notice about the parabola. It has one point on it that is much more important than all the others. The one right in the middle. In this case, it happens to be the origin. It won't always be the origin. We'll see an example in just a minute. But this very important point right here, in this case, it's the lowest point on the parabola. Excellent. It is called the vertex.
I just guessed this one says vertex.
You guessed because on the directions, the very first question says find the vertex. Okay, very good. So that's called the vertex. The second thing you should notice is if I were to draw a dotted line right here, going right through the middle of the vertex, what can you tell me about the parabola?
It's a function.
It is a function, that's true. That's not what I was looking for. If I could fold my piece of paper right along this line and fold it over right along this axis, going right through the vertex, if I could fold that over, what would happen? They would match. And that's called symmetry. So it's like a mirror image. You've got the graph on this side. On this side, you've got the exact same picture. It's a mirror image. And notice there's a pattern in the y values. If I start at the origin and I go one step to the right or one step to the left, what can you tell me about the y values on the graph? They're exactly the same. If I started at the origin and went 2 steps to the right or 2 steps to the left, what can you tell me about the y values? They're the same. If I went 3 steps to the right, if I plugged 3 in, I would get 9. And if I plugged in -3, I would get I would get 9 again. Sorry, 9 again. -3 times -3 is +9. All right, so there's a symmetry property. The vertex is always right in the middle. All right, let's try another one. One a little bit more complicated. Y equals, how about x squared minus 2x minus 3. Once again, if I didn't know anything about parabolas, what I would do is I would build myself a table, and I would plug in 0, and I would plug in a couple of my favorite positive numbers and a couple of my favorite negative numbers. So I plug in 0. When I plug in 0 for x, what do I get?
Yeah.
Not 0.
Should get
Negative 3, because I get 0, minus 3, negative 3. My two favorite positive numbers are going to be 1 and 2 again. Plug in 1. What's 1 squared? 1 minus 2. Negative 1. Negative 1 minus 3. Negative 4. Negative 1 minus 3 is negative 4.
I was saying the 2.
Thinking the 2. Okay, I plug in 2. 2 squared. 4 minus 4. 0. 4 minus 4 is 0. 0 minus 3. Negative 3. Now I'm going to plug, yes, Michael.
Can you write that out real quick? When you highlight what it was like?
Yep. If I plug the 2 in, this would be 2 squared minus 2 times 2 minus 3. So 2 squared would be 4. And then 2 times 2 would also be 4. So I'd have 4 minus 4. Oh, that's 0. And then negative 3 is the only thing left. Okay, plug in negative 1 and negative 2. I'm going to have, I'll write the negative ones out. Negative 1 squared minus 2 times negative 1 minus 3. How much is negative 1 squared? That's 1. And then what happens with a negative 2 and a negative 1? It becomes a positive 2 minus 3. So that one turns out to be 0. Kind of ran out of room there. Turns out to be a 0. All right, now let's plug in negative 2. I'm going to have negative 2 squared minus 2 times negative 2 minus 3. That's going to be 4 plus 4 minus 3. 5. The good news is, in just a few minutes, we're going to talk about a way to draw these parabolas where you don't have to plug in all these numbers. Plugging in these numbers can be time consuming. And of course, when you're doing a bunch of arithmetic like this, it's pretty easy to make a mistake somewhere, isn't it? And then things don't match up.
Is it bad to think like when we multiply it, like the negative 2 and that negative 2? Is that right to think the negative 2 outside the parentheses is the regular 2 and we multiply the negative with? And we just change the 2 signs?
Yep, that would be okay too. All right, so let's draw our picture here. I have 0, negative 3. I have 1, negative 4. I have 2, negative 3. I had negative 1, 0. And I had negative 2, 5. Where's the vertex this time?
1 negative.
Why is 1, negative 4 the vertex? It's the bottom, isn't it? All right, so this parabola comes down like so. Vertex at 1, negative 4. Turns around and goes back up. So here's my vertex.
Is this one of the points?
Questions so far? All right, I'm going to keep building my table a little bit here. I want to now plug in the number 3 without doing any work at all. If I plug in the number 3, can somebody tell me what the y number should be? 0. Yes. Why? You cheated. I said without plugging it in.
Well, it used to be the same as -1, 0. It would be like on the same.
Correct. Notice if I started here at 1, if I went 2 steps to the left, what was my y number?
-1, 0.
-1, and my y number was 0. So if I start here, if I go 2 steps to the right,
Something
it has to be something 0. But if I start at 1 and go 2 to the right, then I've gone to 3. So I should have, it's got to be a mirror image. I've got to have 3, 0. What if I plug in 4? It's got to be 5. How come? It's got to match what it was on the other side. If I got -2, 5, over here, when I go 1 more step to the right, I've got to have 4, 5. Questions?
But it doesn't mirror.
It mirrors, except our vertex moved. So the mirror line is not the axis anymore. The mirror line is always the line
see, okay.
that goes through the vertex. So it does mirror on that line, doesn't it? Yeah, this first one, the vertex was right here, so the mirror line was that axis. The mirror line is always right through the vertex.
It will always mirror, will it always?
Always. Parabolas will always mirror.
Okay.
Always, always, always. Okay, so now to the sheet that I passed out for you. There was supposed to be a picture here. So I'm going to draw a picture. And I'm going to give you 2 points on this picture. This is the point -1, 3. And this is the point 3, 3. The question is, find the x-coordinate of the vertex. I only want the x value. We don't really know what the y value is. The y value looks like it's maybe -1, but we don't know for sure. All I really want is the x value. 2, no. 1, yes. So, I mean, it was either 1 or 2.
2
Right?
over and then 2 over 7.
Yeah, why is it 1? Why does
Weird
that?
to me because I don't have
It has to be 1 comma something. We don't know what it is. Why 1? It's in the middle. The vertex is always in the middle. So what I'm really asking you is, what's halfway between -1 and 3? 1 is halfway between -1 and 3. How do you find halfway in between?
-3 or -1, 0, 1, 2.
Okay. Or, to find halfway in between, you add the numbers together and you divide by 2. It's the average. Halfway in between is the average.
Okay, so if you vertex is 1.
The vertex has x equals 1. I don't know exactly what the y number is. I would need more information. But this question only asked, find the x coordinate. Didn't ask for the x and the y. It has to be 1 because it has to be halfway in between.
So obviously it has to be 1, 6, but
Yep.
so we wouldn't have had to really do that math.
Nope.
This one's easier.
This one's easy. All right, so let's look at the next one. Find the x coordinate of the vertex of the parabola that passes through the points 0, -3 and -7, -3.
I wanted to do the y2 minus 1 thing again.
No, we are never going to do y2 minus y1 in these problems. Why not? What's that?
That's finding, what
Slope of
the
a
slope of a point.
A line.
slope of a line. Are these graphs lines? No, they are not lines. We will never, ever, ever use y2 minus y1 over x2 minus x1 in these problems. They are not lines. They're parabolas.
It's negative 3.5. Yeah.
Negative 3.5. Awesome. How did you get negative 3.5?
I subtracted 7 from 0
And
and divided by 2.
what you should notice is that these have exactly the same y values. If you have 2 points with exactly the same y values, just like we did here, where's the vertex? It's in the middle. It's halfway in between. So our vertex is halfway between 0 and negative 7. What's halfway between 0 and negative 7? Negative 3.5. And the way you would find it is you add your things together, 0 plus negative 7, and you divide by 2. So the x value would have to be negative 3.5. I don't know what the y value is, but the x value would have to be negative 3.5. Negative 3.5.
Alright, say that you have 2 points that have different y value. How do you do that?
You can't. They gotta have the same y value.
So
to be
it
useful.
won't ever be different.
No, they won't. But I might ask you a different question. For example, I might ask you question number 3. I might tell you the vertex is the point 2 comma 5, and the y-intercept is 0 comma 9.
So you find it between the x
Let's think of a picture here. 2 comma 5 would be right here, and 0 comma 9 would be right there. So here's my parabola. The directions are find another point on the parabola.
It would be something that.
It would be something 9, okay? Because you're going to come straight across. 4 comma 9. Perfect. Why 4? To go from here to the middle, I got to take 2 steps. So to go from the middle to here, I got to take 2 more steps. So if I'm starting at 2, 2 more steps puts me to 4. That's exactly right. Questions on that?
Yeah. How did you get 4 again? I know that it's got to be, I mean, the y's got to be 9.
The y's got to be 9, okay? So I started here. To go from here to the middle, how many steps would I have to take? I'm starting at 0, and I'm ending at 2. How many steps is that?
If you were waiting.
If I was right here, and I went to the middle, how many steps? 2. So to get to over here, I've got to take 2 more steps. That's the symmetry of the parabola. So if I took 2 steps, then I'm at 2. 2 more steps puts me at 4.
And when we get questions like that, it'll be easy to count the.
It'll be easy to count. You won't have fractions and decimals on those ones where you're counting your steps. It'll be nice, easy numbers. Okay, so graph the function by hand, find the vertex. Finding the vertex is the most important thing to do. And your author has a really interesting way of doing it, different from any other book I've ever seen, and I really like this. Here's what your author says to do to find the vertex. We're going to build a table. But we're going to do a very strange thing. We're not going to pick a number for x. Rather, we're going to pick a number for y. Very unusual. It's very unusual that you pick a number for y. You're not going to pick any old number for y. You're going to pick whatever this number is right here. So this number is 7. So I'm going to plug that number in for y. So what happens when I plug 7 in for y? I get 7 equals x squared minus 6x plus 7. Plug 7 in for that y right there. How would you solve that equation? Subtract 7. Why do you subtract 7? You got to get 0 on one side, okay? So I subtract 7. I have 0 equals x squared minus 6x. Can you factor x squared minus 6x?
You take an X out.
You can take an x out. Excellent. 0 equals x times x minus 6. What are the answers? You would have x equals 0 or x minus 6 equals 0. So x is 0 or x is 6. So we actually get 2 points here. We get 0, 7 and we get 6, 7. We get 2 points. By plugging in 7 for our y number, we get 2 points. Okay, so we have 0, 7 and 6, 7. Where's the vertex?
In the middle.
It's in the middle. What's halfway between 0 and 6? 3. So now I'm going to plug 3 in for my x number. If I plug 3 in for my x number, I have 3 squared minus 6 times 3 plus 7. So that's 9 minus 18 plus 7. 16. Did you forget about the minus 18?
Or negative 9.
So it's 9 minus 18 plus 7. I think I get negative 2. So I have my vertex is 3, negative 2. Michael.
I'm still at x equals 0 or x minus 6. Like, I thought that there was only one answer.
No, if I have an equation with an x squared, how many answers am I always going to get? 2. And I got 2, right? 0 and 6.
Well, I'll talk to you after.
Okay. So where's my vertex?
3 negative 2.
3, negative 2. There's my vertex right there. Now I draw a nice smooth curve, which you cannot do going through those points. Questions on that? All right, problem B. Pretty much the same thing. I'm going to build a table. I'm going to plug in negative 10, and I'm going to plug it in where? I'm going to plug it in for y. So whatever this number is right here, I plug that in for y. And when I do that, I'm going to get 2 answers. So I'm going to write negative 10 down. I'm going to write it down twice. I know I'm going to get 2 answers. So I have minus 10 equals minus x squared plus 8x minus 10. Why do you think Jay Lehman's the author of the book, why do you think he tells you to use that exact same number? So when you add to both sides, what happens? It's going to cancel out, isn't it? Look what happened. Why did we use the number 7? So when we subtracted 7, they canceled out. Why do we use negative 10? So when we add 10, they cancel out. And then you'll always have something that you can factor, because you'll always have an x squared and an x. You'll always have a GCF. So that's the whole trick. You make these numbers match so that when you add to the other side, they add up to 0. And then you're always going to be able to factor out a GCF of an x. Well, in this case, I don't think we would use x, though. We would use y negative x. Because that first thing is negative. When the first thing is negative, we typically factor out negative. So 0 equals negative x times x minus 8. So we get 2 answers. What are the 2 answers? Not 1. 0 and 8, because you would have negative x equals 0. X minus 8 equals 0. You would divide both sides by a negative. One of your answers is always going to be 0 when you do this. Always, always, always. And then you get a different answer, x equals 8. We have 0 and 8. Where's the vertex? At 4. Why 4?
Not sure. Oh, it's half.
It's halfway between 0 and 8. That's exactly right. So whatever two numbers you get here, you go halfway in between. Halfway between 0 and 8 is 4. Now I need to take the number 4 and plug it in. When I plug in 4, I'm going to have negative 4 squared plus 8 times 4 minus 10. What's 4 squared? Huge. No, 4 squared isn't a huge number. 4 squared is 16, but then I have to do the minus order of operations, correct? We do squaring first. So this is going to be minus 16 plus 8 times 4? 32 minus 10. Minus 16 plus 32. That's 16. 16 minus 10. 6. So there's our vertex, 4 comma 6.
So what we do is when we figure out what the vertex is, I mean the x part of the vertex, which is 4, then we plug that 4 into the original equation, solve it, and then what we get from that will be the y.
Absolutely. So you find these 2 points, you go halfway in between to find your x. Once you know the end of your equation, to find the y. That's exactly right. You said it perfectly. Alright, so picture this time. We have 4 comma 6. Then we have 0 negative 10, which is way down here, and 8 negative 10, which is way over here. And this time we get something interesting. The parabola is flipped upside down. That can happen. So sometimes your vertex is a low point on your parabola. Sometimes your vertex is a high point.
Can you slide it over just a little?
Any guesses on what made it flip over? The negative. If this first number is a negative, your parabola is going to be flipped upside down. If this first number is positive, parabola is going to be the regular way. If this number right here is negative, your parabola will be upside down. Now on this page my grid's printed. I don't know why my grids didn't print on the other pages, but they didn't. Yeah, it looks much better with the grid, doesn't it? Yeah, I agree. Okay, so the directions are just like they were before. The directions ask you to graph, and they say make sure you find the vertex. How would you start? I'm going to build a table. What number am I going to plug in? And I'm plugging it in for y, aren't I? And I will get 2 answers. So I'm going to write 7 down twice. Come off to the side here. 7 equals 2x squared minus 7x plus 7. Now what? Subtract 7 on both sides. I get 0 equals 2x squared minus 7x. Can you factor that?
Take an x out.
You can always take an x out. And that's why we use the exact same number, so they always cancel out. So you will always be able to factor. You will always be able to take out at least an x. X times 2x minus 7. X equals 0, or 2x minus 7 is 0? Uh-oh. 2x equals 7, so x is 7 halves. Bad news, that can happen. You don't always get nice numbers in this world. So I have 0 and 7 halves.
Wait, so once we get it to 0 equals x times 2x minus 7, then
We said each piece equal to 0. So I took x equals 0, I took 2x minus 7 equals 0. And then I had to solve. Add the 7 and divide by the 2.
I'm confused by it, or I don't know why.
Well, how would you get the x all by itself?
Like I'm confused, like x 0 equals x times 2x minus 7, like.
Factored out of GCF. The greatest common factor right there was an
Got that,
x.
and I understand why we got the 0 equals x times 2x minus 7, then after that, like.
Add 7 to both sides, you get 2x equals 7. And then divide by 2.
Okay.
Okay? Now, here's the bad news. What's halfway between 0 and 7 halves? 7/4. How'd you get that? I used my calculator. I was hoping you would say that answer. How do I find it? I take 0 plus 7 halves, which is 3.5. That might be good to know anyway. It shouldn't, won't it? That'll help us to graph. That's 3.5. And then you take that answer and you divide it by 2. We get 1.75, or if you prefer, it is 7/4. Probably going to be better to leave it as a decimal. I think it's easier to graph thinking of it as 1.75 rather than thinking of it as 7/4. Okay, so to draw my graph, I have 0, 7, that's right there. Then I have 3.5, 7. That's right there. And then halfway, oh God, I did a really bad thing. Really, really bad thing. Somebody tell me the really, really bad thing I did?
You label it?
You put a 0.
I put a 0 there. That's not 0. What do I have to do with that 1.75? I have to plug it in. Yeah, I did a really bad thing there. I don't know why I wrote 0. Okay, so I'm going to take 2 times 1.75 squared minus 7 times 1.75 plus 7. I should not have put a 0 there. I should have put a 0.875, which is just a little bit less than 1, correct? 0.8 is just a little bit less than 1. So I got to kind of estimate a little bit here. 1 3/4, and then just a teeny tiny little bit less than 1. So it looks like my vertex should sit right about there. And I draw the picture. All right, so we'll do some more of these on Monday. We'll finish the sheet on Monday. But before you leave, I have a question for you. Where have you seen parabolas in your life? What are parabolas good for?
Graph.
Outside of a math class, what are parabolas good for?
Statistics.
That's still a math class, statistics. Other than these pictures on my paper, where are the parabolas in this room? There are parabolas in this room.
Everywhere.
Architecture uses a lot of parabolas, but I don't see any architecture parabolas in this room. No. No, other than on the screen,
The ducks.
the desks. Maybe the desks, but I don't think so. I don't think the desks are in the shape of a parabola. Ceiling tiles? No, those are squares.
The
Well, I'm just cutting
CCC
up
air
rules.
sticker over there.
The CCC air sticker, no, that's a circle, and those C's are not parabolas, they're half circles.
The projector thing. Your board.
The projector thing, yes. Where?
The top of it.
The top of it,
Oh, no. Sorry, the screen, the edges.
not the edges either. The lenses.
Oh.
It's close together.
Your paper.
This is what your eye looks like. You've got a plastic, not plastic, you've got a clear finish over the top of your eye. In the back of your eye, there's a curve. And that curve is in the shape of a parabola. Your eyes are in the shape of a curve. The lenses in your glasses, the curve is in the shape of a parabola. Your upper lip is in the shape of a parabola. Your lower lip is in the shape of an ellipse. And that's how facial recognition software works. It maps your eyes and your lips. That's why it's very, very difficult to fool facial recognition software. It maps your eyes and your lips. Those are very difficult things to change. The most common use of a parabola, we don't talk about this in this course. A parabola has a point right here in the middle called focus. And here's what happens. Say you have a TV signal coming in. The TV signal will hit the parabola and bounce right to the focus. No matter where the TV signal hits, it'll bounce right to the focus. How's that useful?
Satellites. Transmit stuff.
That's how a satellite dish works. A satellite dish is a three-dimensional parabola. Why does a satellite dish have that arm sticking out of the middle? That's where the focus is. So the TV signals hit that mirror, hit that dish acts as a mirror, and all the signals bounce right to that focus. Here's how your eye works. Light comes in, it hits this parabola, and it bends it, and it goes that way. Comes here, it goes that way. When it comes up here, it bounces and it goes that way. The image all goes to one point, unless your eyes don't work correctly. What happens if your eyes don't work correctly? That's when you need glasses, or I wear contact lenses. What happens is this shape is not quite correct. So the signals, the light waves, don't all bounce to that point like they should. Or they bounce too far back from where your optic nerve sits, or they hit too far forward. And so the glasses correct that.
That's why you can't see far away.
That's the difference. It depends on if it's focusing too far away or too close. And that's why some people need reading glasses and some people need glasses to see distance. Yeah, I can't see far away either. So, okay? So parabolas are actually used in an awful lot of things. You see a lot of parabolas in life. The lenses on my projector here are all in the shapes of parabolas. The lenses on that projector are all in the shapes of a parabola. Your headlight on your car works the other way. The car has a reflective mirror, and the light bulb sits in the middle, and when the light shines, it hits the parabola, and all goes out in the same direction. The parabolas are used in a lot of areas.